Hi everyone, this is M.Revathi, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajasby College of Arts and Science. So in this series, here we are going to see about kernel data structure. So first we see the kernel components. So the kernel components first, the kernel data structures are very important as they store data about the current state of the system. For example, if a new process is created in the system, a kernel data structure is created that contains the details about the process. So most of the kernel data structures are only accessible by the kernel and its subsystems. They may contain data as well as pointer to other data structures. In kernel data structure, the process table and file table is very important. We will see one by one. First one is a process table. The process table stores information about all the process running in the system. This includes the storage information, execution status, file information, etc. When a process pokes a child, its entry in the process table is duplicated, including the file information and file pointers. So the parent and the child process share a file table. Next one is the file table. So the file table contains entries about all the files in the system. If two or more processes use the same file, then they contain the same file information and the file distributor number. Each file table entry contains information about the file, such as file status, that is file read and file or file write, file offset, etc. The file offset specify the position for next read or write into the file. So the file table also contains vnode and the inode pointers, which points to the virtual node and index node respectively. So these nodes contain information on how to read a file. Next we see the vnode and inode table. Both the vnode and inode are references to the storage system, to the file and the storage mechanism. This connect the hardware to the software. So the vnode is an abstract concept that defines the method to access file data without worrying about the actual structure of the system. So the inode specifies file access information like file storage device, read write process, etc. So next we see the list and stack. So an array is a simple data structure in which each element can be accessed directly. For example, main memory is constructed as an array. If the data item being stored in the larger than 1 byte, then multiple bytes can be allocated to the item, and then item is addressed as its item number or item size. So after array, list are perhaps the most fundamental data structure in computer science, where areas each item in an array can be accessed directly. So the item in a list must be accessed in a particular order. That is, all lists represent a collection of data value as a sequence. So linked lists are several types. So there are singly linked list and doubly linked list. So in a singly linked list, each item points to its successor. In a doubly linked list, a given item can refer item to its successors. So the third one is a circular linked list. The last element in the links refer to the first element rather than to null. These are all the concepts of list. Next we move on to the stack. So stack is a sequentially ordered data structure that uses the last in first out. That is called as a LIFO. Principle for adding and removing items, meaning that the last item placed on a stack is the first item removed. So the operation for inserting and removing item from a stack are known as push and pop respectively. An operating system often uses a stack when invoking function call. Parameter, local variables and the return addresses are pushed on a stack when a function is called. Returning from the function call pops those items of the stack. So queue is a in contrast of a stack is a sequentially ordered data structure that uses the first in first out, that is called as a FIFO principles. Items are removed from a queue in the order in which they were inserted. There are many everyday examples of queue, including shoppers waiting in a checkout line at a store and car waiting in line at a traffic signal. Queues are also quite common in operating systems. Jobs that are sent to a printer are typically printed in the order in which they were submitted. For example, tasks that are waiting to be run on an available CPU are often organized in queues. Next one is the hash function and maps. Hash function take data as its input, performance a numeric operation on its data and return a numeric value. The numeric value can then be used as an index into a table. Next one is a map. So bitmaps is a string of n binary digits that can be used to represent the status of the items. For example, suppose we have several resources that are availability of each resources is indicated by the value of a binary digit 0. It means there are sources is available. When one indicates it is unavailable, vice versa. So the value of the position in the bitmap is associated with the ith resources. So we come to the end of the section. I hope you enjoyed this section. Thank you.